The most common smoke detector found in modern houses are ionization smoke detectors. Ionization smoke detectors uses the property of smoke being able to attach to ions to neutralize them. A small amount of americium-241 emits alpha particles. These particles knock off electrons off of the nitrogen and oxygen particles in the air, making them ions. These ions allow a small current to flow from a negatively charged plate to a positively charged plate, located about 1 centimeter apart. When smoke attaches to the ions and makes them neutral, the resistance of current flow between the two plates increases. A small IC microcontroller recognizes these differences and sets off an alarm. Gears allow mechanical rotational energy to be converted between force and speed. For example, a shaft that can rotate at 1 revolutions per minute at a force of 5 foot-pounds will equal the same amount of energy in a shaft that rotates at 5 revolutions per minute with a force of 1 foot-pound. To explain how gears work, we will start with a simple lever that has one side twice as long from the fulcrum. A 10-pound weight can be balanced with a 5-pound weight, but notice when this is done, the 10-pound weight moves half the distance of the 5-pound weight. If we were to change the shape of the lever, where the fulcrum is now a shaft, we have a crank. We can add another lever to make a double crank. Moving the arm will produce 4 times the force on the shorter arm on the left, but will only move 1/4 the distance. To get continuous motion, more arms are added to make levers that rotate. Notice how the smaller wheel of levers has to complete more revolutions to complete 1 revolution of the larger wheel of levers. Modifications can be made to the levers to make them stronger and reduce the friction between them to allow them to interlink smoothly as they rotate. These rotating levers are now considered gears. Gears can be connected to many other gears to reduce or increase the speed even more in a compact fashion. Air conditioning is something we tend to take for granted in our everyday lives. It consists of a mechanical heat pump that removes the thermal energy from the air in a building to the external environment. A mechanical heat pump that is used for cooling a house usually consists of 4 components. The 4 components are the compressor, the condenser, the expansion valve, and the evaporator. In a mechanical heat pump, refrigerant chlorodifluoromethane, or R22, is compressed by either a semi-hermetic, scroll, or rotary compressor to concentrate all the thermal energy into a smaller area, making the temperature of the refrigerant increase. The refrigerant goes into the condenser, where the heat is expelled to the outdoor environment, causing the refrigerant to condense into a liquid. The liquid refrigerant then passes through an expansion valve, which separates the high and low pressure sides of the system. As the liquid refrigerant trickles into the low pressure environment of the evaporator, it rapidly evaporates, absorbing the surrounding heat from the air. The refrigerant is then compressed again to concentrate the heat that was absorbed in the evaporator, starting the cycle all over again. Lenses change the direction of light depending on the shape. Lenses are able to bend light because when the light hits the material, the light slows down differently throughout the lens due to the curved shape, causing the light to curve perpendicularly to the glass. The 2 main types of lenses are concave and convex lenses. Convex or converging lenses bend parallel light inwards, producing a spot at its focal point. The focal length is the distance between the center of the lens to the focal point. These lenses are used in things like telescopes and binoculars to bring distant light rays to a focus in our eyes. Concave or diverging lenses are the exact opposite of convex lenses. Therefore, they cause parallel light to bend outwards. These lenses are used in TV projectors, some flashlights, and other devices that spread out light rays over a distance. Electricity is used to transfer energy from one place to another. Electricity can be easily converted into other forms of energy, such as light, heat, and mechanical energy. That is why it is used to power our homes. Household electricity is an AC current, but to know and understand how AC current works, we first need to learn about DC current. Electricity flows through a conductive material such as copper or aluminum by having electrons flow from atom to atom along the wire. This can be compared to how water flows through a loop of pipe, where a pump forces the water through the pipe. DC or direct current is when the electrons travel in one direction. DC electricity is not good for transporting long distances, so AC electricity is used. AC or alternating current is when the electron flow direction constantly switches between positive and negative. The electricity in our house switches its polarity at 60 times a second, producing a sine wave. The peak voltage of this sine wave is 172 volts, but when we measure the voltage, we measure the average, which is 120 volts. Capacitors are electronic components that can be found in everyday devices. A capacitor stores electrical energy through the potential differences between two plates. Capacitors are used to smooth out ripples from AC to DC rectification, or can be used to store large amounts of electrical energy to allow large current peaks with a lower current supply. When an electrical supply is connected to the two plates, electrons move from one plate to the other. This makes a potential difference that can be released rapidly when discharged. Most capacitors use a dielectric material to increase the capacitance between the two plates. Capacitors are limited to a maximum charge before electrical breakdown. This can vary between different dielectric materials. A farad is a unit for capacitance in a capacitor. A farad is the amount of coulombs per volt. Therefore, if a capacitor can store 135 microfarads at 275 volts, there is 0.037 coulombs of energy stored when fully charged. Shock absorbers use fluid dynamics to dampen oscillations that springs can't absorb. A shock absorber is a cylinder and piston assembly where both sides of the piston are filled with oil. Oil is used because, like all liquids, oil is incompressible. The piston has small orifices that allow oil to be forced from either side of the piston. This causes friction that turns the linear motion into thermal energy. If a car or vehicle doesn't have shock absorbers, the springs will oscillate for a period of time because the energy is stored, not transformed. When shock absorbers are used, the oscillations will be dampened out rapidly. TVs have been around for a long time and are becoming more and more common in our daily lives. Cathode ray tubes, or CRT TVs, use many physics concepts to create a picture on the screen. A stream of electrons are emitted from a heated element in the rear of the CRT. Electrons are able to travel through the empty spaces of the CRT because most of the air has been removed. The stream then passes through an electromagnetic coil, which creates a magnetic field that directs the electrons onto the front of the screen. The electromagnetic coil is able to control the beam to be directed along the X and Y axis of the screen. The electrons collide with a thin layer of phosphorus on the backside of the screen. The electrons cause the phosphorus in that spot to give off light, creating a pixel. The electromagnetic coil moves this spot left and right while moving it up as it creates rows of pixels to fill the display. This cycle repeats 60 times a second, making it seem like the entire screen is lit up at once instead of one pixel at a time. The brightness of each pixel is controlled by how many electrons are emitted when the electromagnetic coil directs it at the desired pixel. If you ever have put a magnet near a CRT TV, you would have noticed that the electron beam would bend around the magnetic field. Most digital and film cameras are able to produce an intense flash of light with a limited power source and compact size. They use a xenon flash tube, which is a gaseous discharge device that is filled with a noble gas, normally a combination of xenon and krypton. A camera has a small switching power supply that inverts the low voltage from the battery, which is around 1.5 to 6 volts, into a higher voltage around 300 to 400 volts. This high voltage is stored in a capacitor that is constantly connected to the xenon flash tube. In order for the noble gas in the xenon flash tube to allow current flow between the electrodes, a trigger voltage of about 5 kilovolts is exposed to the outer premises of the tube. This creates an electrostatic field inside the tube that ionizes the gases, reduces the breakdown voltage of the gas. This causes spark streamers to form between the two electrodes, discharging the capacitor while producing a flash of light. Transistors are the essential building blocks of modern electronic devices. They are a semiconductor device that can amplify and switch signals and electrical power. Transistors have at least 3 terminals that connect to differently doped semiconductor materials. The transistor allows a large current to flow from the collector to the emitter only when a small charge is placed on the base from the emitter. Therefore, you are able to control a large current with a smaller current. There are 2 main types of transistors. These are bipolar junction transistors and field effect transistors. Bipolar junction transistors terminals are base, emitter, and collector. Bipolar junction transistors can have 2 different polarities, NPN and PNP. NPN and PNP describes how the 3 sandwich layers of semiconductor are layered. N is the N-type semiconductor, which is negatively doped. P is P-type semiconductor, which is positively doped. This allows either a positive or negative charge to bias the transistor. Field effect transistor terminals are gate, source, drain, and body, but the body is normally connected to the source. This transistor allows current to flow between the drain and source when a voltage is applied between the gate and source. Internal combustion engines are devices that convert chemical energy into mechanical energy. The most common internal combustion engines are reciprocating and usually consist of 4 cycles. Reciprocating internal combustion engines can also be 2-cycle, but 4 cycles are more common because of their higher efficiency and less pollution. A 4-cycle internal combustion engine consists of a crankshaft that connects to a piston with a connecting rod. As the crankshaft rotates, it converts rotational motion into reciprocating motion, moving the piston up and down in a cylinder. This changes the volume of the chamber above the piston. As the piston moves down, cams that are geared down to half the speed of the crankshaft apply force to the lifters, which then force the intake valve to open. This allows a mixture of fuel and air from the carburetor to enter the combustion chamber. This is called the intake stroke. At the end of the downstroke, the cams lower the lifters, causing the intake valve to shut, and allows the gases to be compressed into a small volume as the piston moves upwards. This is called the compression stroke. Just before the piston reaches the highest point or top dead center, a magnet on the flywheel passes a magneto, generating a high voltage difference between the electrodes of the spark plug. This causes a spark to ignite the compressed fuel mixture. The fuel mixture is ignited before top dead center because it factors in the time it takes the combustion shock wave to reach the piston. The molecules of the gases inside the combustion chamber accelerate or increase in pressure, causing the molecules to collide with the sides of the walls with a greater force. This forces the piston downwards, turning the thermal energy directly into mechanical energy by decreasing the velocity of the molecules in exchange for increasing the velocity of the piston. This is called the power stroke and is the only stroke that powers the engine. A flywheel, which is a large heavy disc that stores rotational energy, is connected to the crankshaft. This stores the energy from the power stroke to be used for the rest of these strokes to keep the engine running. The last and final stroke is the exhaust stroke. This is when the cams open the exhaust valve and allow the piston to push all the burnt fuel gases out of the cylinder to prepare it for the intake stroke. Most passenger aircraft use turbofan gas turbine engines, which consist of an axial dual-spool gas turbine engine that burns kerosene as fuel. Excluding the turbofan, the air is directed through variable inlet guide vanes which direct the air at a certain angle into the first stage compressor blades. The air passes through a series of stator and compressor stages, which compresses the air into a smaller volume, while accelerating it towards the diffuser. When the air is passed through the diffuser, the gases slow down in exchange for an increase in pressure while entering into the combustion chamber. Fuel is then added to the air and burned, causing the temperature to rise and the gases to accelerate towards the multiple stages of nozzles and turbines, which extract some of the energy from the moving gases and turns it into rotational mechanical energy. This rotational energy is then used to power the compressor and the turbofan located in front of the engine. Most of the thrust comes from the air bypass around the engine from the turbofan, while the gas turbine engine produces a small percentage of the total thrust. The Earth's gravity is always pulling us downwards at negative 9.81 meters per second squared, or negative 32 feet per second squared. Therefore, when you are in the field, you will accelerate towards the object by 9.81 meters every second. Gravity is a field force, therefore no physical contact is required to apply force to the object. But since gravity is a field force, the farther an object is from the field, the lesser of an effect it has on the object. That is why all the objects in the universe don't fall into one large mass. All objects will accelerate at the same rate with only gravity acting on it. If you were to launch a 50-gram object with a force of 10 newtons, the object will transfer almost exactly the same amount of force to the ground from which it was launched at. Two-cycle engines are a lot less complex than four-cycle engines due to fewer moving parts, but with the side effect of lower efficiency and usually have a shorter lifespan. A two-cycle engine has a crankshaft, connecting rod, piston, cylinder, flywheel, and magneto like a four-cycle engine, but a two-cycle engine does not have valves and cams. Instead, there are ports on the side of the cylinder that open when the piston moves from the port. As the engine runs, the piston moves downwards, compressing the air-fuel mixture in the crankcase. Right before the piston reaches the bottom of its stroke, an exhaust port is exposed, releasing the residual high-pressure gases from the combustion. Then, when the piston reaches the bottom of the stroke, the intake port is exposed. This releases the pressure from the crankcase into the cylinder, forcing the rest of the exhaust gases out through the exhaust port. The piston then travels upwards, blocking the intake and exhaust port, and compressing the air-fuel mixture above the piston. Also, while the piston travels upwards, a vacuum is created in the crankcase for when the primary intake port is exposed to draw in a mixture of air and fuel from the carburetor into the crankcase. Right before top dead center, a magnet on the flywheel passes a magneto to create a spark to ignite the fuel mixture. The expanding gases force the piston downwards, repeating the first cycle. Since the crankcase does not have an oil reservoir to lubricate the bearings and cylinder like a four-cycle engine, oil is put into the fuel to add lubrication to reduce the friction of the moving parts. Relying on oil in the fuel to lubricate the internal parts of the engine causes faster cylinder and piston wear, reducing the life of the engine. Also, when the compressed fuel-air mixture forces the exhaust out of the cylinder, some of the fuel-air mixture escapes through the exhaust port, reducing the overall efficiency of the engine. Due to the few moving parts, a two-cycle engine can reach much greater RPMs than four-cycle displays, such as TV or computer monitors, are able to produce millions of colors with just 3 colors. These colors are red, green, and blue, and are additive colors. Unlike subtractive colors, additive colors add the colors given off instead of removing the colors reflected. That is why if you mix any two prime colors of paint together, you will get a darker color than before. For instances, cayenne absorbs all colors except cayenne. Therefore, it reflects cayenne. If you mix all 3 prime colors of paint, you will get black, because each color you add subtracts its color. Therefore, you subtract all colors. Since light is additive colors, the more color you mix together, the lighter the color will be. If you add all 3 prime colors of light, you will get white light. The LCD projector image that you are viewing is made up of many pixels that are made out of 3 subpixels. The 3 subpixels are red, green, and blue, and the Z sustain board in the projector can control how much light can pass through each subpixel, making that pixel whatever color needed.